So in this example, I've created this type called student, which would allow me to track information relating to one student. So what kinds of information would I have? Well, students have names, they have a student number, and they have a set of grades, like the grades for assignments or something. Now, we don't necessarily know how many entries this array is going to have per student, but let's assume for any particular course, let's just hope this is still the case in the online era, in any particular course, there are no more than 100 different graded things. But a particular student might not have all of them with grades. Maybe only some of the grades have been entered. Maybe they didn't do some things. Who knows? So what I'll do is I'll have an array to store up to 100 grades, and then I will keep track of how many grades am I actually storing. So this array is only really a buffer. I may not be using all of those things. And what I want to do is write a program that includes some functions to do common operations for students. So certainly I want to create student objects. I want to be able to add grades to their table of grades. I want to compute their average grade among all of the things I have on file. And I want to print out a representation of the student. And so here's some code that works with that. I'll make two students, S1 and S2, and I want to be able to create the student. So I give a name and student number, and then I get back this fully formed student object. It is actually very common. Maybe you've seen in previous examples I brought this up. Why aren't we just using the curly bracket initializer to create the student? Why are we calling a function? Well, one reason is that maybe we later add more stuff to our student object. Maybe we keep track of their email address or something. And having a function that takes care of creating the student means we don't have to keep modifying our curly bracket initializers. But another thing is maybe there's some work involved in creating the student beyond just adding a name and a student number. For example, I have to give some initial values to the grades table. Having a function means I can do that in one central place and avoid bugs. And this style of function, a constructor function, is actually an example of a programming style that persists well outside of C. The idea of a constructor will become a bit of a big deal if you take CSC 116 or CSC 115, which do C++ or Java. So I create students S1 and S2, and then I add some grades to them. Student S1 has these 2 grades. Student S2 has these 3. At any given time, a particular student object may not have the same number of grades around as the other ones. So I call the add grade function. Notice that when I call the function, I pass in a pointer to my object S1 and my object S2 because I want the function to modify the original. And then finally, I print out the representation of the students. Even though I'm only printing the student, and that doesn't need to modify the student object, I will still pass in a pointer to my original to avoid making an unnecessary copy. Because the student objects contain a pretty decent amount of data. They contain a string of up to 100 characters, another string of up to 10 characters, an array of grades. Maybe I don't want to have to keep making photocopies of that, so maybe I'll pass in a pointer instead. Now, one other quick note, why is the student number a string and why does it have length 10? And the answer is, at UVic, what we call a student number, or when I say student number, what I always mean is this representation, V00 and then 6 digits. I guess next year this will finally be a 1 for some people. So the reason I'm storing this in a string is because I think the V is important. I mean, yes, I could just store the numerical part of it, but how do I know that next year they don't change this to like W for some people? So just in case, we'll store that too. So we'll store the whole thing as a sequence of digits, but there are only 9 digits. And so a string of 10 positions, allowing 1 position for the null terminator, that should be sufficient to store a student number. So that's my logic there. And there's a school of thought that maybe we just store that as an int and don't pay attention to the V. But I'm going to pay attention to it just in case maybe in the future it changes. When you're designing a system to work with data, it is good to be a bit liberal as to what you accept as a valid value because you never know whether somebody's going to change their definition a little bit later. Okay, so create student. Let's just run through these functions one at a time. So we're going to return a student object. And the goal is take a name, take a student ID, and then initialize a new student object to contain the provided name and the ID and have its grades array set up so that there are no grades on file. Remember that this idea of the grades array, I don't actually care what's in the grades array except for the values up to the number of grades I have on file. So what I could do is just leave the grades array to contain garbage and then set num grades to be 0. That's a sign to anybody looking that there are no grades on file for the student. Don't go looking for them. All right, so I'll create a new student object. We'll call it st, and I will use string copy to set st.name to be the name of the student. I will use string copy to set st.studentID to be the student ID. And then I will set st.numGrades to be equal to 0. Okay, so I don't have to set the grades array to all zeros. I could do that as an insulation, but I don't have to, because as long as anybody respects the numGrades value that I keep on hand, they shouldn't be looking at elements of the grades array that haven't been used yet. Okay, so that's everything. And I guess I should make sure I call it, for some reason I've called the member student number. Okay, so it's called student number, and then I do that. And then finally, when I'm done, I return st. One quick note, because the structure student contains a bunch of strings, which are arrays, it's natural to wonder, wait, what happens if I try and copy them? Normally, arrays don't get automatically copied. If we pass an array into a function, we're only really passing a pointer. So it's worth considering, when you wrap up an array inside a structure and you make a copy of the structure, everything inside the structure gets copied, including any arrays that are in there. So when I'm returning my student object, I'm returning a copy of everything, including all of the strings that I copied into that object. Okay, so that's create student. Add grade. So what add grade is saying is, you have a bunch of grades on file. Here's a student. Here's a pointer to a student object. I want you to add this grade to the list of grades that you have on file for the student. And remember that the student can have up to 100 grades on file. So I suppose I owe it to myself to check that the number of grades hasn't exceeded that number. And if numGrades is equal to, let's say, 3, then the grades I'm looking for will be in index 0, 1, and 2. So numGrades will always be 1 greater than the last valid index containing a grade. So if I want to add a new one, what I could do is I could say, well, first, let's check that the number of grades isn't already excessive. So let's see, s arrow numGrades. Notice that because s is a pointer to a student object, I have to use the arrow operator or a star and a dot. If s arrow numGrade is already equal to 100, then I've reached the maximum number of grades. So wait, what do I do then? You know, I don't know. There's no easy way of fixing this problem, so I guess what I'll do is I'll say error. Unable to add more than 100 grades. This is a bit of a notional thing. Maybe I shouldn't expect that to happen. And then I'm going to exit the program. If you're in main and you want to exit the program, you can use a return statement. But if I return from this function, that's not going to happen. So I could call this function called exit, which is designed to immediately exit from wherever I am in the program. And I'll actually add and include. Exit is contained in stdlib.h. It's one of those miscellaneous functions. So I'll just call exit. If I can't add a grade, I don't want to run past the end of an array in any case. So if I want to add a grade and the array is full, I just say, sorry, program's over. Go fix the programmer now has to fix the problem. Otherwise, I'll say, okay, let's go into the grades array, and I will set the next index available, which will also happen to equal the current number of grades. If there are 4 grades on file, the last grade will be at index 3. So index 4 will be the index I can put the next one. Get rid of the J I put there. And then I will increment the number of grades on file. All right. And then that's the end of the add grade function. Now, compute average grade. So given a student object, compute the average of all the grades we have on file. And of course, there's the special case. Wait a minute, what happens if there are no grades? The student has no grades at all right now. So I'll handle that first. If s arrow numGrades is equal to 0, then I will just return -1. Okay, so that's not a program ending error, because there is an escape strategy defined for that. And then otherwise, I want to loop over all of the grades on file and compute the average. So I'll just keep track. Here's my average here. Average equals 0. And then I will run a loop over all of the elements up to s arrow numGrades. And then average plus equals s arrow grades sub I. So I'm allowed to go into I follow my pointer s to the student object it refers to. I get the member called grades, and I index that at index I. Okay, so I add that in, and then eventually I will divide the average by the total. So that would be s arrow num grades, and I will return that. All right, and then finally, print out a summary of the student's name, student number, that's already being done, and a list of grades. Okay, so all I have to do here is I start at 0, I loop up to s arrow num grades, I++. And then at each step, I'll just print out the grade by itself. We'll do %2f, and then a space, and then when I'm done, I'll print out a new line. And one thing that's interesting to consider here is that, oh, there's the new line, is that it's actually sort of hard to test any of these functions until all of them are written. Certainly, I can't test add grade until I can print the student out, because how do I know if the grade was added if I don't print the grade back out when I'm done? I have no idea if the compute average grade works until add grade works, which means print student has to work so I can test add grade. And I can't do any of that stuff until I have create student working. So there is a bit of an investment associated with being able to run this code and test it. So that means if there's a mistake, I've written a lot of code since I last compiled. So if there's a mistake, I could have to pick through a lot of stuff. Oh, whoops. And here there's an error. Hopefully that's the only one. It looks like I have a colon instead of a semicolon. So we'll cross our fingers. That's all I have to worry about. Okay, and so then we'll try running this. All right, so let's go down and take a look at what we expect. So student S1, this is their name, this is their student number. That looks good. The grades that I've added to them are, to S1, I have called add grade to add 90 and 100. And that means there are 2 grades on file, so the average should be 95. And it is, that looks good. Let's see what happens if we have 3 grades. So here's this student. Looks like their name and student number are correct. Their grades are 50, 75, and 100, and how convenient. The average there should be 75, and it is. So this is actually a pretty typical example of the workflow you would see in a program with functions to work with structured data. We use a structure type to organize our data, and then we pass in usually pointers to various functions to perform specific tasks. And we can sort of mix and match them. In the next video, we'll give a brief tour of maybe using this in a larger scale setting.